Alright, this is where we were last time. We prove these statements up here, these three. Let's look at this fourth statement and see. Let's erase this work that we did here. Now, u dot u, what is that equal to? U dot u, according to what we have, it's supposed to be the horizontal is multiplied u1 times u1, because you dot the thing there, the vector on itself. And by the way, just to take a little break and see, remind you should remember anyway, that when you have the vector, you have the horizontal and the vertical component, right? This is the horizontal component of the vector. And the vertical, I took it for granted before that you remember, but you should remember that this is the vertical component of the vector. So u1, vector u, is u1. So if this was vector u, we would call this u1 and this u2, right? u1 plus u2. It's kind of look like v. u2. Now, what is that? Oh, it looks like u1 squared plus u2 squared. That's what it looks like, right? Now, the thing is, if you have this, it looks as if what you have is some sort of right angle triangle. And you call this u1, you call this u dot u, I mean. And this is u1 and this is u2. So if you say u1 squared plus u2 squared, u1 squared plus u2 squared would be this squared. Alright, oh, I had put, my mistake, I shouldn't put that. This is just u. Now, if you say u1 squared plus u2 squared, you're saying this side squared plus the other side squared equal this side, the hypotenuse squared. You see that? No, the hypotenuse squared, when you square root that, you get the length of the hypotenuse, which is the length of u, which you write like this. Alright? But let's not square root it, put it as squared. What this seems to be saying is that u, the length of u squared, the magnitude of u, or they call the modulus of u squared, is equal to u1 squared plus u2 squared, according to Pythagoras theorem. But this is equal to this. u1 squared plus u2 squared is equal to u dot u, right? And u1 squared is equal, u1 squared plus 2u2 squared is also equal to the magnitude of the vector u squared. So therefore, the magnitude of u squared is equal to u dot u, which shows this statement here. Alright? So, we showed all of those statements to be true. So, in our next video, we look at this again, and we can put some numbers to some examples.